In the year 2025, China accomplished something that sounded almost unbelievable a decade earlier. It built 157 kilometers of the Beijing-Hong Kong-Macau Expressway, not with armies of construction workers wielding shovels, hammers, and heavy vehicles, but with 10 autonomous machines that move in perfect formation like a metallic phalanx, each guided by satellites, sensors, and artificial intelligence so advanced that it made thousands of independent decisions every second. Decisions about pressure, compaction, speed, trajectory, and alignment, all of which together created the first large-scale highway project in human history completed almost entirely without human labor on site, a feat that marked not merely an engineering milestone but a glimpse into the way the physical world itself may be built in the future. This new stretch of expressway, carved into the Golden Channel, that connects the industrial heart of the Pearl River Delta with the political and economic core of the North, was more than just a road. It was a lifeline, a trade artery, a passageway for millions of vehicles carrying raw materials, consumer goods, workers, families, and travelers every single day. And yet for all its importance, the expressway had long carried a darker memory burned into China's collective mind. The nightmare of October 2015 when, during the National Day holiday, more than 750 million people set out across the country, and at one infamous toll station 50 lanes of traffic were forced into just 20, creating one of the worst traffic jams in recorded history. A frozen river of steel stretching beyond the horizon, a nightmare so surreal that from helicopters it looked like an industrial glacier, still and lifeless, a living picture of Carmageddon that embarrassed China's leadership and exposed the limits of even its massive infrastructure programs, proving that human labor, no matter how vast, could not keep pace with exponential demand. And so, what seemed like a humiliation became a turning point, a seed planted for a radical idea, that roads, bridges, and entire cities of the future might be constructed not by larger and larger human crews, but by intelligent machines that could work tirelessly, precisely, and relentlessly, guided by satellites and algorithms, capable of building with millimeter accuracy and zero fatigue. And by 2025 that vision was ready to be tested as 10 machines lined up at dawn on the Beijing-Hong Kong-Macau Expressway, their steel bodies glinting in the morning light, each one humming not with the noise of a driver grinding gears but with the steady, controlled rhythm of artificial intelligence executing perfect choreography. At the heart of the convoy was the SAP 200 C10PA, a gargantuan paver with a screed nearly 20 meters wide, able to lay 4 full lanes of asphalt in one continuous ribbon, a sight that to onlookers resembled a mechanical whale exhaling heat as molten black asphalt glowed beneath it, followed by platoons of rollers in a 1+3+3+3 formation. First, the double-drum steel rollers pressing the surface while it was still malleable, then the 30-ton rubber-wheeled rollers compacting it to a density so uniform it seemed poured from a mold. And the most astonishing thing was not their brute force but their awareness, each vehicle adjusting its speed, spacing, and pressure autonomously, not from human commands shouted across dust-choked air but from streams of live data fed through Beidou satellites, LiDAR scanners, infrared thermometers, and pressure sensors, all fusing together into decisions made in milliseconds, micro-adjustments imperceptible to the human eye yet critical to ensuring a flawless surface. Safety, long the Achilles heel of construction where accidents and fatalities haunt every site, was transformed by digital fencing that projected invisible barriers around each machine, stopping them within milliseconds if an obstacle intruded, while real-time hazard detection and instant communication allowed the fleet to move like an orchestra. If one machine paused, the others adjusted in seamless synchronization, never colliding, never drifting, always in formation. Perhaps most remarkable of all was the achievement of zero-edge rolling, a problem that had plagued human operators for decades, where compacting asphalt right up to the pavement's edge without crumbling curbstones or leaving gaps was an art only a few crews could master. Yet the autonomous rollers performed it with millimeter precision every single time, leaving edges so clean that engineers inspecting the finished lanes called them the finest they had ever seen, surfaces that looked as if they had been carved by laser. The calmness of the site itself was uncanny, with no shouts of foremen, no cacophony of instructions, no chaotic motion of dozens of laborious darting between colossal machines. Only the steady hum of engines, the hiss of asphalt spreading, the measured rhythm of an intelligent ballet unfolding on the earth, a construction site more like a laboratory experiment than a human workplace. And behind this silence was not the absence of people but their relocation. Supervisors monitoring from distant control rooms filled with screens displaying compaction graphs, thermal maps, and GPS grids. Their role no longer to command but to observe, refine, and intervene only when necessary, while the machines themselves collected and stored petabytes of construction data to refine their algorithms, learning how to build faster, stronger, and more efficiently in every subsequent project. And so what unfolded on the Golden Channel was not simply another road project but the quiet birth of a new paradigm. For millennia, from the cobblestones of ancient Rome to the interstates of the United States, infrastructure had always demanded sweat, muscle, and endless armies of laborious. But here in 2025, China demonstrated that a highway, the very backbone of civilization's arteries, could be built almost entirely without human hands, ushering in a vision where skyscrapers, bridges, ports, and cities themselves may one day rise not from shouted orders and human toil, but from the steady, flawless choreography of machines. And the questions this raises echo far beyond engineering. Will such autonomous construction prove safer, faster, and cheaper than human methods? Or will it displace millions of workers and reshape economies? Will the silent precision of AI crews replace the noise of human sweat and instinct? Or will it evolve into a hybrid future where machines and people build together? And as we drive across roads built not by laborious but by algorithms, we must wonder, are we witnessing merely the future of infrastructure, or the dawn of a world where the very foundations of our civilization are laid down by machines that learn, adapt, and build without us? Safety, economics, and the human element were the three great forces circling around China's Golden Channel project, and in many ways they defined its meaning far beyond the laying of asphalt. Because for decades, road construction had been one of the most hazardous professions on Earth, a job where men and women spent endless hours under scorching sun and freezing winds, surrounded by deafening noise, choking dust, unstable ground, and vehicles rushing past at lethal speeds only a few meters away. Conditions that led to injuries and fatalities so frequently that they were almost considered part of the profession. Yet the promise of autonomous construction was that no longer would human beings have to stand in those danger zones. No longer would they risk their lives within reach of massive steel rollers or in the blind spots of dump trucks. Instead, the front line would be held by machines guided by radar, cameras, sensors, and digital fences that projected invisible barriers around each vehicle. Barriers that responded not with hesitation or distraction, but with absolute precision, stopping entire convoys within milliseconds if an obstacle crossed their path, an achievement beyond even the most disciplined human crew. Every machine in the 10-vehicle formation not only saw the world through its own eyes, but also through the eyes of its companions, sharing streams of data in real time like a digital nervous system, so that if the lead paver detected a flaw in the surface, or slowed by a fraction, the rollers behind instantly adjusted their speed and spacing to maintain formation, a ballet of steel that required no shouted commands, no radio chatter, no human error, only seamless machine logic that traveled faster than a blink. And the result was not only greater safety but also greater efficiency, for in traditional projects delays, miscommunication, and fatigue often led to mistakes requiring costly rework, while here the system corrected itself before an error could even form. And so the economic implications were staggering, because a project of this length under conventional methods would have required hundreds of laborious across multiple shifts, with costs ballooning from wages, overtime pay, housing, food, and logistics, whereas the autonomous model reduced the site workforce to a small cadre of supervisors and engineers, highly skilled individuals who watched from air-conditioned control rooms filled with screens displaying pressure graphs, temperature maps, and live video feeds, intervening only rarely because the machines themselves handled the bulk of adjustments, which meant that while the upfront investment in these robotic crews was immense, Their ability to work tirelessly day and night without fatigue, sick leave, or human error turned them into long-term cost savers, delivering surfaces so flawless they exceeded national standards. Policymakers in Beijing saw more than a road. They saw a new economic model for infrastructure itself, one that could cut timelines dramatically, save billions in labor costs, and keep vital arteries like the Golden Channel open with minimal downtime, a crucial advantage for a nation whose expressways carry the lifeblood of commerce every single day. But even as economists praised the model, another question rose like a shadow. What would happen to the workers whose jobs these machines replaced? The thousands who had once relied on seasonal contracts to survive, men and women whose livelihoods came from laying asphalt by hand, guiding rollers, and shoveling aggregate, suddenly finding themselves obsolete in the face of algorithms and hydraulic arms. And while critics warned of displacement and unemployment, supporters countered that this was not the end of human labor but its transformation, for someone would still need to design the systems, maintain the machines, service the sensors, and program the algorithms, turning the future workforce from muscle-bound crews under the sun into data-savvy technicians in monitoring stations. And in this way, the Golden Channel echoed debates that had already shaken factories, farms, and warehouses worldwide, showing that the same automation reshaping manufacturing, logistics, and agriculture had now reached the beating heart of infrastructure, one of humanity's oldest and most labor-heavy industries. For centuries, road building had been synonymous with sweat, shovels, and muscle. Yet here in 2025 the image shifted to robotic formations gliding with alien calm, so precise it unsettled older veterans who felt their trade vanish before their eyes, even as younger engineers felt, or as if witnessing construction rise to the technological level of aerospace and microchip manufacturing. And for the supervisors the change was dramatic too. Their role now more like air traffic controllers than foremen, scanning endless streams of telemetry and patterns, analyzing system behavior, watching as machines learned and improved on their own, and realizing that intervention was no longer their primary job but interpretation. Universities across China began rewriting their curricula, preparing the next generation not for shovels and drills, but for coding, machine learning, and robotics maintenance, nurturing a new class of specialists who could command fleets of autonomous machines rather than individual vehicles. And so the Golden Channel was not just a road but a case study in how technology rewires an economy from the ground up, how safety, cost, and labor transform together when the front line is no longer human. And as foreign observers watched, the ripple spread outward, with Japan announcing tests of robotic construction ahead of the 2030 World Expo, the European Union quietly studying the model, and even the United States, despite its rivalries with Beijing, funding research into autonomous infrastructure. But what set China apart was not just vision but execution, because while others debated and drafted policies, China simply built, gathering more data, refining algorithms, and accelerating a feedback loop that made every project smarter than the last. And this is why the Golden Channel will be remembered not just as a highway but as a declaration, a line drawn in asphalt that announced to the world that the age of human-only infrastructure was ending, and that the future would be written in code and steel rather than sweat and stone, a future where roads, bridges, and tunnels still serve people but may no longer be built by people, a future where entire cities could rise through the tireless labor of intelligent machines guided by satellites and sensors, a future where construction itself becomes as precise, efficient, and automated as the factories that build our cars and phones. And as we imagine that horizon, we are left with a question as profound as it is unsettling. If machines can already build our highways, what comes next, and how much of civilization's foundations will soon be laid not by us, but by the algorithms we create?